Hi there! This is an attempt to make a video. I would like to be able to say with a tiny bit of confidence that this is a video, but I've tried this a few times and they've all failed. So I'm just going to call this one an attempt. I'm not going to expect it to work, and maybe the low expectations will work out okay. So we're going to do some stuff. We're going to talk about multiplication and division. We're going to use an obtuse scaling triangle to do something. We're going to drop an altitude because it's trig, so it's going to be fun. We're going to do some trigonometry on the left side of our picture. We're going to do some Pythagorean theorem on the right side, and we're going to apply the Pythagorean identity. That's all the stuff we're going to do, because we are deriving the law of cosines. That's what this project is all about, deriving the law of cosines. But first, there's going to be an algebraic maneuver in here that seemed to catch some people like a little confused. So let's talk about multiplication and division. When you were very, very small, they taught you these things, right? And they didn't teach you division first. They taught you multiplication, and then they taught you division. The reason for that is that those two operations are actually the same operation. One is just going one way, and the other is going the other way. So if we take a fact, I'm going to put 3 times 4 equals 12 up here, okay? 3.4, okay, equals 12. Now that fact you learn is not any different from this fact, that 4.3 equals 12. And that fact is no different from the fact that 12 divided by 3 equals 4. And that fact is no different from the fact that 12 divided by 4 equals 3. Here it looks like I've written 3 different equations, but I've only written one idea. And that one idea is that if I say, hey, let's divide something into 4 parts this way and 3 parts this way, that how many parts will there be? That a 3 by 4 is a total of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. That's what's going on there. So if I want to say, hey, I got 12 things, and one side of it is 4, what's the other side? It's got to be 3, all right? So this relationship right here is all of that stuff, all right? Now, let's go ahead and get to be a little bit older and not use this division symbol. Actually, we do use that division symbol, but instead of having a thing on top and a line and a thing on the bottom, we have a thing on top and a line and a thing on the bottom. Where the dots go, the values go in. So we can say something like, put a 12 up here and a 3 down here to get a 4. Or we can put the 12 up here and put the 4 down here and get the 3. Same facts and all that kind of stuff. All right? So we'll be aware of that as we do a little bit of work in just a moment. Okay, so I've got a line segment here that's got a side length, a point, see an endpoint of C and an endpoint of A. What I'm going to do is get an endpoint of B in there, but I want that B to be somewhere up high, all right? So I'm going to throw in a B here. Plan is to get an obtuse scalene triangle. So that's why I picked a point. You know, I don't even like where that is. I'm going to scoot it over a little more. Maybe somewhere around there. We'll call that point B. Look how dirty my finger got. All right, so let's connect here line segment CB, which of course, opposite our triangle, is going to be side A. Oh, isn't it nice how the lines, you know, how putting this tool on the board doesn't erase all the work you just did? All right, let's go ahead and do this one here. Oh, fabulous. Opposite angle C, that must be side C. I wanted to be really clear that this C is big and this C is small. And honestly, guys, whoever wrote the alphabet, if you're still out there, come on, really? I mean, O and O, S and S, C and C. You just ran out of ideas. I mean, what was going on with A and A, H and H? Even P and P, man, I can tell this guy from that guy, you know? And then you were doing amazing things and you were like, ooh, Q and Q. But then you come around and like C and, oh, I'm out of ideas. I mean, dude, that was the very beginning. You know, you were already out of ideas at that point. That's so sad. But here we are, stuck using the beginning of the alphabet and whatever work that fool came up with. So, here we are. Let's drop an altitude. I'm going to use this thing because maybe it'll erase less stuff, all right? So let's see. Multiplication, division, obtuse scaling triangle. Yes. Oh, by the way, let's make sure that angle's obtuse. Here's a right angle in there, all right? Is it bigger than that? Why, yes, it is, okay? You can do these other ways, but I want you to learn how to do it this way because it's just tidier, okay? So here we go. We are going to drop an altitude. Now I've had an affinity for doing red altitudes for a while, so let's just stick with that. How do you know it's an altitude? Because, of course, it meets that base at a right angle. Let me get out of the way so you can actually see it. Oh, it's so pretty. All right. So our next thing, do trig on the left. So here's what I'm going to do. Oh, by the way, I didn't do this. That's B, so all of this is B. So let's go ahead and name that whole thing. It's B all the way. Well, we've got this broken into two parts. We've got a part over here, we've got a part over here, right? And we've got this altitude. I'm going to name that little part on the left something. I'm going to name that altitude something just for the short run. Let's call this height, all right? Sometimes we use A, but A's taken, all right? So let's call this K, because K is just such a fun letter to put with H. Remember how we did that with circles and stuff like that? Maybe you do, maybe you don't, I don't know. And the vertex form of a quadratic, that was so fun. What is it? Something like y equals a times the quantity a minus h squared plus k. Oh man, h and k, they're so fun. The circle, x minus h, the quantity squared, plus y minus k, the quantity squared, equals r squared. Oh, it's beautiful, just beautiful. Anyway, so we got a height in here. I'm like, oh, what the heck, I got h, may as well throw k in too, because, you know, whenever you take h, k's like, me too, you know. So, can't have one without the other. Yeah, you can, actually, though. Anyway, let's do some trigonometry. This angle C has a sine, so it is true that, oh, it's not working green, that's just crazy. All right, the sine of C is equal to h over a. This is why we were talking about multiplication and division. That's a number. That's a number, that's a number, okay? Thing over thing equals other thing. Look, thing over thing equals other thing, right? You know what? Let's call this top thing over bottom thing equals thing on the right, all right? If I do bottom thing times thing on the right, I've got 3 times 4. What's 3 times 4? Oh, it's top thing, okay? So this is going to translate to the fact that, so I'm going to say therefore, h equals a sine c. Now some people seem to be shaking their head at that. Where did that come from? All right? Oh, the only place it came from is let's multiply both sides by a. Put an a there, put an a there. And now you got ha on top and ah on the bottom. A over a is 1. Boing, boing. Those are gone. A sine c equals h. H equals a sine c. So it's pretty quick. So that's how that goes. That seemed to be a sticking point on trying to talk about this. People are like, I don't quite know what's going on here. So you watch this, you get smarter. All right? Great. So I'm going to actually erase that stuff because I don't want us having to do those intermediate algebraic steps, because those intermediate algebraic steps are fantastic if you're a freshman. You're not a freshman. If you are a freshman, hey, hi, I'm Mr. Scheidler, and you're not supposed to be watching this video. It's secret. It's only for juniors. All right. So a sine c is h over a, and so h is a sine c. So love you, h, but we're going to call you what you actually are. There you were in disguise, but now we know you're actually a sine c. Yeah? Meanwhile, good old k down here, you divide it by a, it was true that the cosine of c, the adjacent over the hypotenuse, was k over a. So cosine c is k over a. Therefore, k is a cosine c. A cosine c. Feels to me like I'm going to run out of board. That's what that feels like. So let's go ahead and put that in, what that actually is. A cosine c. Now, because I'm going to run on the board, I'm going to let you just watch this, and I'm going to get rid of all these other things that we don't need, like this division problem here, and that fact, and that fact. So that was just a derivation of something, okay? Oh, one more thing that we need. Dig this. If all that was, say, 7, and this much of it was 4, then that would be, must be 3, right? Ooh, the power of subtraction. See? Whole thing, the whole thing minus a part equals the other part, right? So that part right there is, I need more room for this, b minus a cosine c. Yeah, I need more room there. Just get rid of those little bars. That's what it is, b minus a cosine c. Tidy that up a little bit. All right. b minus a cosine c. All right. Do we need those other facts? If you want them back, we can put them back there. That the sine of c was, well, the h is gone there, so I'm not going to see h anymore. So I'm not going to put it back, because why do I need what h equals when h isn't even in this picture? So that's a sine c, that's a cosine c. So there we go. But now what we're going to do, we did trig on the left, we are going to look on the right side. So we're going to take a look at this triangle right here. Pardon me whilst I try to draw something not sloppy. Fail, fail again, fail again. I can't do anything right. Well, I can do some things. But anyway, there's a right triangle, right? So we're going to do the Pythagorean theorem, which is that something squared equals something squared plus something squared. Yes, I know, you probably want to say a squared plus b squared equals c squared. You'll get to say it too, almost, okay? But what we're going to say is hypotenuse squared, well actually a squared plus b squared equals c squared is leg squared plus other leg squared equals hypotenuse squared. Well, we're going to flip that around to hypotenuse squared first by saying this. C squared equals leg squared plus leg squared. So we're going to square a leg, and we're going to square the other leg, and we're going to add them together. So we don't think we're raising something to the 2 cubed power. We don't think we're raising to the 8th. We'll just get rid of that fact as well, okay? And we've got that. Doesn't mean the fact is no longer true. Erasing things doesn't actually change the universe. Oh, if only it did. All right, so let's put a sine c right here for one leg, and b minus a cosine c for the other. A sine c, b minus a cosine c. Ooh. Now this one here is just squaring a product. This is a times the sine of c times a times the sine of c. Which is a times the sine of c times the sine of c. So nice that mathematics allows us to write this succinctly. So we shall succinctly write that the sine of c times the sine of c is the, it's too much words, but we have a squared sine squared c. Just distributed the 2 there and there. Just plop it down. Don't plop the 2 under the c, because we're not saying take an angle, square it, and then take its sine. We're saying take an angle, find its sine, and square that. Okay. The other part, to do this, I would like to review something kind of simple with x's and y's. So I'm going to jump over here and then erase it, okay? If we happen to have x minus y, and we're squaring that, one of our special products, remember those from once upon a time, is that this is x squared minus 2xy plus y squared. Great, that's known. So we don't have to do all our work. We don't take this, write it next to itself, do the arcs, and do all that kind of stuff. Again, fabulous work if you're playing like with dollies and stuff. But if you're in high school, you should be able to look at this and just square it lickety-split. So this is the first thing squared minus 2 of the product plus the second thing squared. So the first thing squared is pretty simple. B squared minus 2ab cosine c plus, real key here, man, because negative y times negative y is going to be positive y squared, all right? So we have plus a cosine c, the quantity squared, which is a squared cosine squared c. So the same thing we did here to here, we're doing there to there, okay? A squared cosine squared c. We look at this big long thing, all of which is equal to c squared. Pardon me, guys. Nice to have you around, special products, but go away. And now we have all that. Of course, it goes away, but it remains with us in our hearts. So here's an a squared term. Here's a b squared sitting by itself. Here's some big globby goopy with all kinds of things in it. Here's an a squared term. We can combine like terms. I'm just going to pick this up, plop it down there and say, ooh, let's factor out the a squared. So we have a squared times sine squared c. Oh, what am I doing? Closing my parentheses. I get a little ahead of myself sometimes. That's just crazy. All right, plus cosine squared c. Ooh. Minus, wrong, plus b squared minus 2ab cosine c. All right, I'm going to put some stuff in there and then erase it. I just want to make sure I have everything, okay? So let's use this little red guy. Here I've got an a squared sine squared c. I've got all that. Here I've got an a squared times the square of the sine of c. Here I've got a plus b squared. Here I've got a plus b squared. That's cool. Here I've got a minus 2ab cosine c. Here I've got a minus 2ab cosine c. Excellent. And here I have a plus a squared cosine squared c, which is a plus a squared cosine squared c. Let's take a look at this. Is there anything up here that's not down here? Every single symbol, plus and minus and all that, is accounted for. Every single letter, every single number, every single trig function, it's all there. That's grand and glorious and great and groovy and other things that start with G, but not gargantuan. You'll get a longer equation later on. Maybe I'm being goofy. That starts with G too. You know what else starts with G? gracious sakes, which is what I'm going to say when I try to watch this video and I'm told, we can't find it because the software the district bought you is about the crappiest thing in the whole wide world. It's like you go to a wedding and they're about to have dinner and you sit down and they give you a wet Twinkie. I mean, who would do that to you? I'll tell you who would do that to you. Proviso would do that to you. One proviso. Oh, apparently I'm proviso proud. Right now I'm feeling a little bit of proviso shame because I'm using this particular software. But what are you going to do? It's called Crazy Video Maker. Crazy. It's crazy because it made me crazy for trying to make this video. So, hey, look. Sine squared plus cosine squared. We're about to apply the Pythagorean identity. Now, of course, you remember that the sine squared of theta plus the cosine squared of theta equals 1. Lots of projects worked on that. Wow. And it doesn't matter whether we're talking about theta, or whether we're talking about alpha, or whether we're talking about beta, or whether we're talking about c. It don't matter. Whatever you have, take the sine of it, square that. Take the cosine of it, square that. Add those two together. You get 1, no matter what. Always true, always awesome. So this is just a fancy way of saying 1. And a squared times 1 is just a squared. And so what we have, the c squared equals a squared plus b squared minus 2ab cosine c. And this glorious discovery is the law of cosines. No, not the suggestion of cosines, not the pending legislation of cosines, not the strong recommendation of cosines. This is the law of cosines. And it is the Pythagorean theorem for every single triangle. Now, you might think, oh, this is so hard to remember, in which case I will retort with, no, it's not. First part of it, c squared equals a squared plus b squared. That's just the Pythagorean theorem. What about this other part? Well, I would like to take you on a little voyage back to a long time ago when we learned that trig-based triangle area formula, which was that the area of a triangle, when you're given two sides and the included angle, is, I'm putting a plus in here on purpose, even though we never put that there before, 1/2 AB sine C. And what I would like to point out to you, if I could, with this thing that I could point with, so, is the opposite of plus is minus. 1/2, and I'm going to say opposite because opposite actually does mean negative, but the inverse of it, and the inverse of addition is subtraction. The inverse of 1/2 is its reciprocal, which is 2, sitting right there. A and B and C are just A and B and C. They're just in that same order. Sine function? Ooh, that's fun. What's the second one? I know. Some people want to say secant. They're like, ooh, sine secant tangent. And I love that too. But right now we want to go sine cosine tangent, and tangent is sine over cosine. So on the unit circle, we have sines and cosines. So what do we have besides sines? We got cosines. 1/2 A plus 1/2 AB sine C is over here all by itself. If you know that, and you know the opposite of plus, and you know the reciprocal of 1/2, and you know the other trig function besides sine, and you know not even the whole alphabet, just the first 3 letters, A, B, C. You can write that down. Then you can say, oh, let's flip it all. Let's flip plus to minus, flip 1/2 to 2, and flip sine to cosine. And look, c squared equals a squared plus b squared minus 2ab cosine c. It's my opinion that these two things are kind of like siblings in a way. You know, if you know that one, you know this one. If you know this one, you know that one. So some people might say, I got to memorize this one, and then I got to memorize this one. Well, you already memorized this one. That was the Pythagorean theorem, and you did that when you were about 4, right? So, and this one, maybe you're thinking, hey, I never learned that. All I'm saying is this: 2 plus 2 is 4, right? But if this thing is like 4 difficult to learn, and this thing's like 3 difficult to learn, you put them together, it's not 5 difficult to learn, okay? Because learning is super additive. Honestly, the more you know, the more you can know. So don't be like, I can't do that. Because it's like, I can do that and more every single time. All right, well, we're hitting about 20 minutes here, and this has probably all been completely futile, but go ahead and marvel at the derivation of the law of cosines. And then what I'd like you to do is think to yourself, I can do this too. So go ahead and practice it, and that's your job. Show that you can derive the law of cosines. Thank you all so much. Have a fantastic, whatever it is that you're doing right now. If it's night, good night. If it's morning, good morning. If it's, well, there's not a whole lot other options than that, are there? I guess there's day. Good day.